Textbook questions, biodiversity and physiology of body systems, and we're looking at gas exchange, question 3. Multicellular organisms. So if you remember, what does that mean? An amoeba is a single cell, whereas you, the fish, other mammals, are lots of, trillions of cells. Part of their body surface modified to form specialised respiratory surfaces, and describe the 4 properties. And we've got 4 lines there, 2 marks, so you can imagine that if you get them all right, you'll get 2, and you might not get any for 1 or 2 suggestions here. Hopefully you can just reel these off. So, large surface area. You need to say surface area. You can't say SA. So it could be anything, that could be South Africa or all sorts of things. So large surface area. Then we've got thin, and that would be related to a short diffusion distance. And as we're talking about fish and mammals here, we can talk about a good blood supply. So good you might be thinking, well, some way of maintaining a concentration gradient. Those are general properties, but it's asking us actually about fish and mammals. So a large surface area of the lungs or the gills, thin alveoli surfaces, or gill lamellae, good blood supply, capillaries, blood vessels in both gills and lungs. And the last one, well, these gases have got to get across from the air or the water into the blood, and so the membranes must be permeable to these gases, oxygen and CO2. 2 advantages, and there's 2 marks, so there'll be 1 each there, to a mammal of having internal. So we can't talk about the fish, we need to talk about the mammal, and internal means inside. And it's not really going to be any of these up here, so we've mentioned these already. So you might think, well, large surface area. Well, that would be an answer, given advantage of a mammal having lungs, but it's going internal lungs. So that's the key thing in this question, internal. What's that internal bit got to do? Got to do with being an advantage. And the 2 real reasons. I would suggest the main reason is to prevent water loss. So if you have these outside, you lose a lot of water by evaporation, whereas the infoldings would prevent you do still get water loss from your breath, but you're getting less than if they were external. And likewise, the same thing to prevent heat loss. If you breathe on your hand, you can feel the heat. If your lungs were external, you'd lose a lot of heat. Part B. Both fish and mammals have ventilation mechanisms. And now, do we know what ventilation is? Well, ventilation, if you open a window for some ventilation, it's letting the air in. Why do fish and mammals do that? Well, with fish it's to move the water, with mammals it's to move the air. But where and for what reason? So, to move, I'm going to call it the respiratory medium. So, water or air, in those two examples, to move this respiratory medium over the respiratory surface the lungs or the gills. And why? Well, that will bring in oxygen or remove CO2. Or another alternative thing you can say is to maintain the concentration gradient for oxygen or CO2. So in your lungs, for example, you're breathing or ventilating to keep the oxygen concentration high in the alveolar air so that it will then diffuse into the blood. Name the muscles, so we're just giving the names, which operate the ventilation mechanism in mammals. So there's the muscles around your ribs, intercostal muscles, and we don't need to really mention internal or external, but just the name, because it's not mentioning breathing in or out specifically. And also this diaphragm at the bottom of your thorax, so diaphragm, that's how that's spelled. Right, here's a diagram of gill plate and gill filament in a fish, and we are adding arrows to complete relationship between the flow of water and the flow of blood. So we just need some arrows on here. So if this gill, water's flowing over this, we'll put the water on first. So the water is kind of flowing over this gill like that. So use labelled arrows. So we're going to have water. This is water coming. You only need one, but I've put three on just to make the point. And then, what do we know about the flow of blood in a fish? Well, it's a counter current, so against the flow of water. So we've got the blood is going through these gill plates in the other direction. And we're going to label that again, label, so blood there. What term, so it's not going to be a long answer, is used to describe this relationship? Well, we said it already, counter Caspar current. Counter current. And why does this increase the efficiency? Well, there's a statement that we're always going to say in this situation, and we've got this situation here where the entire length of this gill plate, we've got a concentration gradient for oxygen and CO2, of course. So no matter where we are on this gill plate, we've always got a concentration gradient, and so we can get exchange of gases across this entire gill plate. So maintains concentration gradient for gases, oxygen, CO2, over the entire gill plate, there. And so exchange can happen over that. And that's 12 marks.